Hello, welcome to this lesson. In this video, we are going to solve this example I have here. The question says a bin of 50 manufactured parts contains 3 defective parts and 47 non-defective parts. A sample of 6 parts is selected from the 50 parts without replacement. That is, each part can be selected only once and the sample is a subset of the 50 parts. How many different samples are there of sizes that contains exactly 2 defective parts? And then also, as an additional computation, find the total number of different subsets of sizes out of what, the 50. So let's look at how you are going to solve this question. Okay, so we have a bin of 50 parts, okay, and then out of the 50 parts, 3 of them are defective and then 47 are non-defective. Okay, 3 are defective and then 47 are non-defective. Okay, 47 are non-defective. Okay, so the question is saying that how many different samples or are there of sizes that contains what, exactly 2 defective parts. Okay, so what this question is asking us to do is that we are carrying out an operation, okay, and then that operation is to get a sample of what sizes that contains what, exactly 2 defective parts. Okay, and then the question is saying that how many different ways are there that you can carry out what, this operation. Okay, so in this case we are going to have just 2 steps because you are supposed to choose you are supposed to have what, a sample of what sizes, okay, and then that sample must have just 2 defective parts. Okay, and then the bin contains just defective and then non-defective. Okay, so if 2 of the 6 are defective, then that means that what you have to do next is to choose the remaining 4 out of for the non-defective. So in this case, you are just going to have 2 steps forward to the operation, where this will be step 1 and then here will be what, step 2. Okay, so in this case if you are relating to this to the multiplication rule, okay, if you are having a number of, if you're having an operation to carry out, okay, in this case our operation is to select what, a sample of sizes that contains what, exactly 2 defective parts. So if you have this operation, okay, and then with this operation it has what, a number of steps, in this case 2 steps, and there are n1 different ways to carry out step 1, then n2 different ways to carry out step 2, then the total number of ways to carry out the operation will be the product of what, the number of ways for these 2 steps. Okay, so in this case we know our step 1, then we know our steps 2. So what you have to do is to find the number of ways that you can carry out step 1 and then find the number of ways that we can carry out what, step 2, and then after that we find the product of those two to get the total number of ways to carry out what, the operation. So the total number of ways to carry out step 1 will be n1, and then the total number of ways to carry out step 2, okay, this is for step 1, and then the total number of ways to carry out step 2 will be n2. Okay, so our goal here is to find n1 and then what, n2. Let's look at that. So to find n1, which is the total number of ways to carry out step 1, okay, that is going to be we have 3 defective parts and then you want to select 2 out of the 3. So we want to look at the number of ways that we can select 2 defective parts out of the 3. In this case you see that that doesn't matter here, okay, because you are just selecting defective part. The one I'll select first doesn't matter. Okay, you just want 2 defective parts out of the 3, so that's going to be 3 combination 2. Okay, so we are going to look at the number of possible ways that we can get 2 defective parts out of the 3 that's available. So that's going to be 3 factorial. Okay, 3 factorial divided by 2 factorial, so multiplying 3 minus 2 factorial. Okay, so that's going to be 3 factorial divided by 2 factorial. Okay, 2 factorial multiplying 1 factorial. Okay, and then when we do this we are going to have 3 times 2 times 1, okay, divided by 2 times 1 times 1, right? And then this is going to give us 3 different ways. That means that you can carry out step 1 in 3 different ways. So our n1 will be equal to 3 ways. Okay, so now let's find our n2. which is the number of ways to carry out of step 2. So for that one also, we are going to have 47 non-defective parts, and then you have to choose what 4 out of it. So that's going to be 47 combination 4. We're going to have 47 factorial, okay, divided by 4 factorial, okay, multiplying 47 minus what 4 factorial. Okay, let's see what you are going to get for this. So this is going to give us 47 factorial, okay, divided by 4 factorial, okay, multiplying what 43 factorial. Okay, let's see what you are going to get for this. So you're going to have um you're going to have 178, okay, 178,365 365 different ways, okay, different ways. So we can pick uh, 4 non-effective parts out of the 47 non-effective in 178,365 different ways. So we know the number of ways that we can carry out of step 2 also. So all you have to do is to find the product of all these two steps, okay, and then that will give us all the total number of ways that we can carry out the actual operation. So let's look at that. So we are going to have 3 times 178, okay, 365, okay, so this is going to give us a value of 535,095, 535,095 different ways. So we have 535,095 different ways to select a sample of what sizes that contains what exactly 2 defective parts. The second question also says that as an additional computation, find the total number of what different subsets of what sizes out of what the 50. So we want to find the total number of what subset of sizes that we can get out of what the 50. So that's going to be 50 combination 6, because you're not considering order in this case. That's going to be 50 factorial divided by 6 factorial multiplying 50 minus 6 factorial, right? That's going to give us 50 factorial, okay, divided by 6 factorial multiplying what 44 factorial, right? This is going to give us a value of 15,890,700. So you're going to have 15,890,700, okay, different ways